What is actually delta ferrite? Where does it come from and what's the impact? I will explain you in this short video. Hi. With regard to delta ferrite, we often figure in our daily business, especially with regard to pharmaceutical applications, the question, is delta ferrite a topic for the application? Is it a problem for the application or it is not? In order to figure if this is the case, I brought you some samples here, and these are, well, in this case T-pieces, which are certainly showing weldings here and there. And the question is, do these T-pieces differ from each other or are they the same? First, you will figure they are the same, but if you take a probe like this, which is a ferrotoscope, and measure the weld seam with regard to their magnetic susceptibility, you will feel and you will figure significant differences in there. And the question is why? When you take a look now with a microscope to the weld bead here, you will figure that you have little black marks within the weld seam. And these little black marks are actually delta ferrite. Those delta ferrite is a chromium-rich crystallization that does not crystallize within the original austenitic structure, but it's a ferritic structure. So the question is, why does that happen? In order to understand that, we would need to have a look at the carbon iron diagram with a vertical cut at 72% iron and have a look at the nickel and the chromium content of these different phases which are in there. So when you cool down this heat system, you will figure that during the cool down phase you will create chromium-rich crystals, and the rest of the heat will face a lack of chromium at some point. When you cool it down more and more, you will figure that those chromium-rich crystals will remain, and they are the delta ferrite in these weld beads. So what can you do in order to estimate what you will receive? In order to estimate that, you would need to use a Schaeffler diagram. This Schaeffler diagram consists of empirical data, and they consist of a nickel equivalent and the chromium equivalent, and whatever alloy you are having, you can insert that into the Schaeffler diagram, and it will predict the delta ferrite that you will receive during welding. The question is it right? Can we also find that during our experimental results? And in order to verify that, we did a lot of investigation and a lot of weldings that we were doing on the one hand, 1.4435 BN2 heats, and on the other hand, pure 316L heats. You see the result up there, and you will figure that 1.4435 BN2 has an average delta ferrite of roughly 2%, whereas the 316L has an average of roughly 5%. So there are 3% difference. And the question is, does that matter? Is that harmful for your application or is it not? The Basler chemical industry did a lot of investigations on that, and they figured that the delta ferrite is relatively harmless and does not infect the basic corrosion resistance of your metal, of your alloy, when it's limited to roughly 2%. So you can figure that using pure or standard 316L, you will have an average of 5, and you will go beyond that. You will end up at 8, 10, that depends a bit. So there is for some applications certainly a need to reduce that. And the question is, how can we reduce that? Do we look at a standard single part only? Can we probably solution anneal that part? That would be a solution for smaller geometrical parts that you can put in an annealing furnace. For larger components, for complete systems, that's certainly not an option. So you would need to use nickel-based alloys, either as a wire or as a welding ring that you insert into your welding. Another option would be to use so-called ferromix shielding gas, and this ferromix shielding gas contains of nitrogen. Nitrogen is a very strong austenitic builder, so it will shift the whole scenario, the whole system, the whole weld bath towards the direction of austenitic structure and will move it away from ferritic structure. Well, that's actually what you can do about it, and I hope I could give you a little bit of an idea on if your application is affected by the need for a reduction of delta ferrite or not. If you have further questions, we would certainly be very happy to receive those, and we would furthermore be very happy if you would subscribe to our YouTube channel and if you would give us a thumb up. Thanks so much.